Hi, everyone. Thanks for having me here today. My name is Diana Zhao, and I'm Virgin Hyperloop's Senior Director of Global Business Development. And I'm here to talk about how Hyperloop and rail can work together. Now, some of you guys may have heard of Hyperloop, but others may be newer to the idea and wondering why is Hyperloop here today when we're talking about rail and about the future of rail. So I want to start this session by giving you a brief introduction to the technology and the unique opportunities that I believe it presents. Hyperloop is a new mode of transportation that can allow passengers or cargo to travel in a near vacuum environment at speeds of up to 1,000 kilometers an hour with zero direct emissions using magnetic levitation and electric propulsion. It can connect cities like metro stops, essentially. With Hyperloop, our vehicles, which you see here, we call them pods, they can carry passengers, up to 28 passengers, or cargo, and they're very similar to an electric vehicle. They accelerate gradually via an electric propulsion system through this low pressure tube that you see here on the slide. The pod floats along the track using our proprietary magnetic levitation technology, and it glides at airline speeds for long distances due to the ultra low aerodynamic drag inside of the tube. And all of this is tied together with our autonomous control platform. There are no drivers or pilots on the pod itself. And when you put all of this together, when you put several Hyperloop pods together into a network, it becomes something like a long-range autonomous vehicle network. Think of AVs, but going at faster speeds in a dedicated environment without the safety hazards of running into people or other external factors and connecting between cities instead of within cities. Today, we are already dealing with the effects of pollution, lack of access, and congestion, and the industry needs to adapt and evolve to meet sustainability goals. The number of cars is set to double worldwide by 2040, same with air and trucking. And transport is the largest contributor of greenhouse gas emissions in the UK, representing 27% of all emissions. And you can find similar statistics in other countries around the world as well. If we only invest in the same technologies we've had for more than a century, then tomorrow will look very much like today, but much worse. And meanwhile, the rise of industries, the rise of e-commerce especially, has increased the demand, the need for on-demand transport and logistic services. So the question is, how can the industry meet increasing consumer demand while decreasing carbon emissions? And that's exactly what we want to deliver with Hyperloop. Beyond just revolutionary technology, we want to achieve ambitious and necessary goals and reimagine what public transportation is, essentially setting the standard for 21st century travel. Let me talk about some of the benefits of Hyperloop. 10 times more energy efficient than air when we're talking about short haul flights. We've also done some analysis on a project in India where a single Hyperloop system between Mumbai and Pune could reduce carbon emissions by over 150,000 tons per year. That's the yearly equivalent to powering over 26,000 homes or removing 30,000 cars from the road. And in the Middle East, a Hyperloop system could move over 45 million passengers per year, fully powered by the sun. When you look at all of these numbers, Hyperloop becomes a very compelling solution to this problem. I'm going to actually flip back because I think, sorry, I'm going to flip back to a slide that I think was skipped. And for some reason, it is not flipping to that middle slide. But anyway, I'll talk to it. One of the questions that we get asked in this conference is, why are we here today as part of this rail and engineering, civil engineering conference? Now, we believe that the Hyperloop and rail industries and other industries, in fact, as well, can work together to create an integrated transportation network. We can do that because we believe we are complementary modes of technology. By moving people and cargo off the roads and onto other forms of transportation that support the efficient movement of large groups of people, mass transit rather than individualized travel, Hyperloop systems could link with existing rail lines and create an integrated network. Rail is great at linking distances of up to 300 kilometers or even 500 kilometers apart, but when you get above that, there is a limit to the amount of time that people are willing to spend in transit without jumping to the next form of transportation, which is air. So Hyperloop, we believe, can extend that reach, could connect distances that are between 500 to 1,000 kilometers apart at very compelling speeds, and thus expanding the reach of the rail network. Hyperloop could be that missing link, effectively, between rail and aviation. At Virgin Hyperloop, we also believe that this new technology opens up additional opportunities for partnership with the rail industry. For example, we have several very prominent rail infrastructure owners and operators that are currently investors in us because they see a lot of similarities in the capabilities and requirements between being a rail operator and being a Hyperloop system operator. So in this age where we are constantly testing the boundaries of what we can accomplish, Hyperloop can really provide new opportunities. And we're doing this in the way not just that we are designing the system, but also in the design process. So I know there was a session right before this one on the value of digital twins. We recognize that there is tremendous value in creating digital versions of our system as well, and we've actually incorporated a lot of this into the design process of the Hyperloop system. There's value not just in construction and from an asset management perspective, but also from an operational perspective. So being able to simulate the size and management of our Hyperloop pod fleets in order to address and meet passenger demand and meet certain performance requirements, such as energy usage, minimal wait times, etc. And all of this is aggregated into a dashboard so that these metrics can be monitored in real time. And it's actually very similar to what the speakers before me were talking about. So what you see here are several Hyperloop pods traveling in a convoy, meaning that they are virtually coupled together. They're traveling in one tube to their destination, while you can kind of see in this picture here, in the other tube, there are pods traveling in the other direction. Using the powerful processing and visualization tools that we have today has been really a key aspect towards deploying this new mode of transportation. And actually, we think that there could be benefits to other industries outside of Hyperloop as well. Uh-oh. I don't know if somebody can help go back to the screen right before. Can I get some help with the internet clicker, please? It's the one right after this slide, please. Yes, thank you. Okay, on November 8th, 2020, we made history when our co-founder and our CEO, Josh Geigel, and our head of passenger experience, Sarah Lukian, were the first people in the world to travel safely on a Hyperloop. The number one question that we get is Hyperloop safe? And with this recent passenger test, we've successfully answered this question, demonstrating not only that Hyperloop can safely put people in a pod in a vacuum environment, but also that the company has demonstrated a thoughtful approach to safety, which has been validated by an independent safety assessor. The testing campaign, which from the beginning stages all the way to the end, was overseen by an industry-recognized independent safety assessor, or an ISA called Certifer. They are a world-renowned safety firm that does this for rail and other transport modes as well. And just to highlight some of the key aspects of this test, this was a near vacuum test. So we took all the air out to reach 100 pascals of pressure inside the tube. We accelerated the pod to 172 kilometers per hour. And a question that I get asked a lot is, is that the top speed for this? No, that's not the top speed. We've been able to achieve actually higher speeds of more than 370 kilometers an hour from a testing capacity, but the acceleration required to achieve those speeds would not have been possible with passengers on board. So we had to lower the speeds for this. But regardless, the demonstration was extremely exciting for us, and it showed that the system could work. Okay. Oh, next slide, please. This is not just a system for passengers. We're also working to transform the face of cargo and freight logistics. Imagine a Hyperloop connecting an airport to a warehouse on the outskirts of the city, or a port to a regional distribution facilities. I mean, these are some of the examples and the different cases that we've been looking at today. The picture that you see here imagines how Hyperloop could interface with a port. Hyperloop-enabled cargo systems could support fast, sustainable, and efficient delivery of palletized cargo, enhancing speed, reliability, and reducing delays. But Hyperloop doesn't just get from point A to point B faster and cheaper. When you think about what Hyperloop could do from an entire supply chain perspective, it could revolutionize supply chain manufacturing, enabling just-in-time agile manufacturing practices. It can expand freight transportation capacity by connecting with existing modes of road, rail, ports, and air transport, and can provide greater connectivity between manufacturing parks, economic zones, distribution centers, et cetera, et cetera. So I could go on talking about the benefits of the technology, how it's coming to life, but I'll stop here now. This is obviously a very extremely exciting time to be in the transportation and mobility space. I'm really excited about what Hyperloop could do to transform the mobility of people and of goods. And I'll open it up for questions now. Thank you.
Hello, Diana. Thank you so much for your presentation and for joining me now for some questions. While we just wait for our audience to filter through those questions, they can use the chat box on screen to send through any questions for you. But while we wait for those to filter through, I've got a few of my own for you. So can you talk me through some of those main challenges when it comes to, working out how Hyperloop infrastructure will really connect seamlessly with the existing rail network?
Sure, and actually, this is something that we get asked a lot, which is how can Hyperloop be integrated with not just the existing rail network, but the aviation network, with bus systems, with roads and with highways as well. And one of the key design aspects of us, as we're looking at talking with different transportation planning departments and looking at how Hyperloop can be integrated with the urban fabric and the rural fabric of what already exists today. We've looked at a bunch of different things in a bunch of different ways in which you can share, for example, stations. That's one way in which we could be integrated with a rail system. So due to the unique aspect of the tube and the track, you can't move directly from a rail system onto a Hyperloop system, though we are also looking at that as a potential future generation. But having kind of the way you would having a platform in which you could, for example, transfer from a rail system to onto a Hyperloop pod, and you could do a cross-platform transfer. That's one way in which you could be integrated with the existing rail system today. So I think a lot of this is really about appreciating what is already there and not actually coming in as a new technology, really integrating with the modes of transport and the infrastructure that's already there, and figuring out how can we make this better for the passengers? How can we actually create a seamless passenger experience? We've done a lot of work around also understanding how people use systems and use transportation systems like Hyperloop. And I would actually encourage all of you to go onto our YouTube channel and watch our passenger experience video, which we released earlier this year, which imagines the entire experience for people taking the Hyperloop system from getting into, from the ride sharing system to a Hyperloop portal or Hyperloop station onto the pod, traveling through the station itself, getting onto the pod, how the entire experience feels when you're inside the pod, then getting out on the other end. And so it seems like a very simple and straightforward experience almost, but there's been a lot of thought into the design of the integration of the Hyperloop system into the urban fabric of a city, for example, and the entire passenger experience. And I would encourage all of you guys to take a look at that video on our YouTube channel.
That's great. Well, I mean, talking of passenger experience, we've got a question that's come through from Manoj Gupta from Waterman. He says he might be asking this a bit too early, but what are there any thoughts on when Hyperloop systems will be ready for passengers, and how much will it cost to ride? And have there been any feedback from trials so far?
Yeah, so very good question. Actually, questions. So we are we've been in conversations with many departments of transportations and many planning organizations and private companies as well that are looking to build Hyperloop systems all around the world. Um, from a passenger perspective, we are targeting the end of the 2020s, the end of this decade, to be operational for passengers. So 2028, 2029, somewhere around there. The cost will really vary depending on the location. So it's very difficult, unfortunately, to give a generic ticket cost. But the way we've designed our system, and actually the reason why it is in a vacuum and in this kind of structure, it reduces operating costs quite a bit when you're taking out all of the air from the system and you're reducing the drag. So the amount of energy that's required to power each pod forward is much less than comparative modes of transport. So we believe that it's something that's going to be very comparable to rail and to existing modes of surface transportation. It's not something that is luxury travel. It's not something that's going to be made for the very, very rich. This is something that is going to be mass transit, is something that's going to be affordable to all. And it really will depend on the location and the areas that we're connecting itself. The last question around sorry.
No, go ahead. Sorry,
I
Diana.
The last one around testing and feedback on the system itself and the design of the passenger experience. I mean, we've run through the design of the actual passenger experience. We've run multiple focus groups in several different locations throughout the world. I believe we've done focus groups in India and Europe and also in the U.S. And we've looked at how people behave in those scenarios, and also what is important to them in the experience of traveling. And so we've taken a lot of that feedback and we've integrated it and incorporated it into the design of our pod and all the features of our pod. Unfortunately, at this time, we haven't opened up our test asset for non-employees to use, so we can't really speak to that. But we're hoping at some point soon we'll be able to allow, roll this out for the mass population.
That's great. So we've got another question that's come through from David Sharrocks from LBA. He says, in a developed country like the UK, do you envisage steel tubes on pylons, or do you envisage tubes being underground tunnels?
Yeah, both could actually work. One of the advantages of the system is that because it's in a tube, and because of the way we've designed the tube, it's a much lighter infrastructure than rail. So even if you're building across the same terrain, you've got smaller pylons, you've got, um, you don't need quite as much foundational and civil works as you might with, building a highway or building a rail line. And so we've designed the system so that it's high capacity, but at the same time, it has a much smaller and much more nimble and lighter footprint than other modes, than other types of infrastructure. Um, with regards to tunneling, and again, because we are in a vacuum and because we're in a tube, we can have much smaller tunnels, which I'm sure this audience knows means much cheaper tunnels, potentially exponentially cheaper tunnels when you have a much smaller diameter for tunneling. So all of these, factor into ultimately the cost of the system, but we can run alongside the same alignments that rail can, and ultimately whether or not we build on pylons or in tunnels, that's really going to depend on where we're building.
And you touched on freight during your presentation. Simon Pledger from RLB says, how would you take sea containers or their contents into a Hyperloop pod solution?
Yeah, I mean, the way the rendering that I showed you is currently designed, that pod, it can take cargo, but it can take palletized and airplane cargo. So right now it's not big enough to carry an entire container, but you can take the components out of the container and put it onto the pod itself. So we are looking at a couple of ways in which perhaps we could take containers directly. I think that is still kind of an open question, but right now the idea for cargo is that it is using smaller containerized or palletized um, goods instead of the full TEUs or FEUs.
Okay, unfortunately, that's all we've got time for today, but thank you so much for joining me, Diana. It is such an exciting project, and we look forward to seeing how the work progresses. Thank you.